In this video, I would like to discuss in more detail some of the open source libraries for feature engineering, because we're going to make heavy use of them in the next sections of the course. We mentioned that there are a number of libraries for feature engineering, like Scikit-Learn, category encoders, feature engine, feature tools, and imbalanced learn. And Scikit-Learn, category encoders, and feature engine have exactly the same functionality with the methods fit to learn the parameters from the data, and then the method transform to perform the transformation. Feature tools is very useful for transaction data, but doesn't share this functionality, so we won't be discussing this any further. And imbalanced learn doesn't transform features individually, it resamples the dataset to try and tackle data imbalance. Scikit-Learn has a battery of transformers to transform data to tackle various aspects of the variables. For example, it has the simple imputer to perform mean, median imputation, imputation with the frequent category, or to add an arbitrary value, and it has the iterative imputer to perform multivariate imputation. It can also perform one-hot encoding with the one-hot encoder, or replace strings by numbers with the ordinal encoder. It has a variety of transformers to scale the features in different ways, like for example applying standardization, or scaling to the mean and maximum value, or scaling with the median and the interquartile ranges, among others. It has a class to perform discretization. This is to sort the values of the variables in contiguous intervals, and this one can apply discretization into equal width, equal frequency, or k-bins, and it can also transform the variables mathematically with the power transformer or the function transformer. It can combine features with polynomial expansion, and it can also extract features from text. The advantage of Scikit-Learn is that it runs on top of NumPy, so it's very fast. A downside is that it applies the transformation to the entire dataset. So we need to use another class to slice the dataset first, like the column transformer, if we want to apply the transformations only to a subset of features. Feature Engine also has a variety of transformers with the fit transform functionality to perform a lot of transformations. It has a lot of transformers for missing data imputation, including mean and median, random imputation, imputation with a value at the end of the distribution, frequent imputation or imputation with the string missing, adding a binary indicator, and some more. It has more variety of options to encode categorical variables. It can also remove outliers from the dataset. It can, of course, perform discretization, transform the variables with several mathematical functions. It has a Scikit-Learn transformer so that it can wrap a Scikit-Learn class so that we apply that only to a subset of features. And then it can also combine features with mathematical functions. Category encoders, as I mentioned previously, is designed to encode categorical variables, and it has the widest collections of techniques to encode variables into strings. Some of them are listed here, but to get more familiar with this package, I recommend you jump onto the website because they have a lot of references into each one of these methods. Some are very straightforward, like the ordinal encoder or the one-hot encoder, but some are a little bit more complex, like the backwards difference encoder, the base encoder, and the feature hashing. Now, as I mentioned previously, the beauty of using these packages is that we can apply all the transformations as part of the pipeline. So, obtaining raw data, transforming it completely so that we can use it to train a machine learning algorithm becomes very simple. We need to only import the necessary transformers, load the data, then accommodate all the transformers within a Scikit-Learn pipeline, followed by a scaler if we need, and the model that we want to train. And then with pipeline.fit, we fit all the transformation steps to the data, and with pipeline.predict, we obtain the predictions for any dataset that we want. Here we have another example where we create an imputation step, and with Feature Engine we can indicate which variables we want to modify within the imputer, so this imputer will apply the imputation only to the variables indicated here. We can set up another imputation, encoding real labels, and then transforming these strings to numbers only for the selected variables. And at the end, we can add a gradient boosted machine, for example, or any other algorithm that we want. So once we accommodate all the transformations within a pipeline followed by a machine learning model, we only need to do pipeline.fit and pass the training set and the target to learn the parameters from the end to the end of the pipeline. And then with pipeline.predict, passing a train set, we obtain the predictions for the train set. And with pipeline.predict for the test set, we obtain the predictions for the test set. And more general, with pipeline.predict, whatever data we pass, we obtain the predictions for that data. And we can save the entire pipeline in just one pickle. So if we're going to load this from an API or from another notebook or from another computer to score data for some of our colleagues, we just need to load this one single pickle to obtain the predictions from the complete raw data. With this, let's try and redo our feature engineering pipeline, now using open source.